Okay, so we're looking at homework from section 3.2. We're looking at problem number 14, which is one of my favorite problems in this entire book. We're going to determine the probability that at least 2 people in a room of 13 people share the same birthday, ignoring leap years and assuming each birthday is equally likely, by answering the following questions. First, compute the probability that 13 people have different birthdays. Then, the complement of 13 people have different birthdays is at least 2 share a birthday. Use this information to compute the probability that at least 2 people out of 13 share the same birthday. So, for part A, we're trying to find the probability that 13 people have different birthdays. So when you look, I've set up 12 slots to fill in. You may ask yourself, why is it 12 and not 13? Well, that's because when we are doing this problem and the first person out of the 13 is evaluated, they set the standard. Whatever their birthday is whatever it is. And then each person down the line, person number 2, 3, 4, 5, 6, now we want to know the probability that that person has a birthday different from the first person and every other person in the line. So when we look at the second person, the probability that their birthday is different than the first person is 364 out of 365. When we move to the third person, now we want to know what's the probability that their birthday is different than the first 2. And that's going to be 363 out of 365. Then we move to the fourth person, and we want to know what's the probability that their birthday is different than the first 3. So we've already had 3 birthdays taken up, which means there's only 362 left out of 365. And we continue in this fashion. The numerator just keeps going down by 1 every time, all the way down to the 13th person, which is our 12th slot, which is 353 over 365. We multiply these together, and this is very definitely a calculator problem. The probability of all of them having different birthdays. So when you're entering this into your calculator, do the numerator as a multiplication problem. So do 364 times 363 times 362 all the way down to 353 and hit enter. Then hit the division sign on your calculator. So you're dividing by, put a parentheses, put 365 to the 12th power in the parentheses and end that parentheses. And then when you hit enter, you will get 0.8055897248, which rounds to 0.806. So that's actually kind of an astonishing number. This says there's basically an 80.6% chance that all of them have a different birthday. But that really means that there's a pretty large, significant probability that at least 2 of them will have the same birthday. And that's what part B is asking about. What's the probability that at least 2 of these people share a birthday? So that's the complement of all 13 having different birthdays, which would be 1 minus the probability of all of them having different birthdays. So the probability of at least 2 having the same birthday is 1 minus the probability that they all have different birthdays. We just computed that value in part A. So this is 1 minus the 0.806, which is 0.194. So that means there's a 19.4% chance that 2 people out of 13 will have the same birthday. Almost 20%. It turns out that if you get about 30 people in a room, the probability that at least 2 of them have the same birthday is up above 90%. So that's why I like this problem so much, because it really reveals something kind of cool. And that's your answer.